CIET NCERT presents the audiobook Ganit Prakash, Textbook of Mathematics for Class 6.
Chapter 1 Patterns in Mathematics. Page number 1, 1.1. What is mathematics? Mathematics is, in large part, the search for patterns and for the explanation as to why those patterns exist. Such patterns indeed exist all around us, in nature, in our homes and schools, and in the motion of the sun, moon, and stars. They occur in everything that we do and see, from shopping and cooking to throwing a ball and playing games, to understanding weather patterns and using technology. The search for patterns and their explanations can be a fun and creative endeavor. It is for this reason that mathematicians think of mathematics both as an art and as a science. This year, we hope that you will get a chance to see the creativity and artistry involved in discovering and understanding mathematical patterns. It is important to keep in mind that mathematics aims to not just find out what patterns exist, but also the explanations for why they exist. Such explanations can often then be used in applications well beyond the context in which they were discovered, which can then help to propel humanity forward. Page number 2. For example, the understanding of patterns in motions of stars, planets, and their satellites led humankind to develop the theory of gravitation, allowing us to launch our own satellites to the moon and to the Mars, and send rockets. Similarly, understanding patterns in genomes has helped in diagnosing and curing diseases, among thousands of other such examples. Figure it out. 1. Can you think of other examples where mathematics helps us in everyday lives? 2. How has mathematics helped propel humanity forward? You might think of examples involving carrying out scientific experiments, running our economy and democracy, building bridges, houses or other complex structures, making TVs, mobile phones, computers, bicycles, trains, cars, planes, calendars, clocks, etc. 1.2 Patterns in numbers. Among the most basic patterns that occur in mathematics are patterns of numbers, particularly patterns of whole numbers. 0, 1, 2, 3, 4, and so on. The branch of mathematics that studies patterns in whole numbers is called number theory. Number sequences are the most basic and among the most fascinating type of patterns that mathematicians study. Table 1 shows some key number sequences that are studied in mathematics. Page number 3, Table 1, Examples of number sequences. In the first row, it is given that there are all ones. In the second row, there is a pattern 1, 2, 3, 4 and so on. These are called counting numbers. In the third row, there is 1, 3, 5, 7, 9, 11, 13. These are called odd numbers. In the fourth row, 2, 4, 6, 8, 10, 12, 14, and so on. They are called even numbers. Fifth row, 1, 3, 6, 10, 15, 21, 28, and so on. These are called triangular numbers. In the sixth row, 1, 4, 9, 16, 25, 36, 49, and so on. These are called squares. In the seventh row, 1, 8, 27, 64, 125, 216, and so on. These are cubes. In the eighth row, we have 1, 2, 3, 5, 8, 13, 21, and so on. These are called Viranka numbers. In the ninth row, 1, 2, 4, 8, 16, 32, 64. These are powers of 2. In the last row, 1, 3, 9, 27, 81, 243, 729, and so on are powers of 3. Figure it out. 1. Can you recognize the pattern in each of the sequences in table 1? 2. Rewrite each sequence of table 1 in your notebook along with the next 3 numbers in each sequence. After each sequence, write in your own words what is the rule for forming the numbers in the sequence. 1.3 Visualizing number sequences. Many number sequences can be visualized using pictures. Visualizing mathematical objects through pictures or diagrams can be a very fruitful way to understand mathematical patterns and concepts. Let us represent the first 7 sequences in table 1 using the following pictures. Page number 4. Table 2. In the first row, there is a row of green dots with 1 dot at a time. So that will represent all ones. In the second row, there is 1 red dot, then 2 red dots, then 3 red dots, then 4 red dots, and so on. These will represent counting numbers. In the third row, 1 blue dot, followed by 3 blue dots, 5 blue dots, 7 blue dots, and 9 blue dots. These are representing odd numbers. In the fourth row, 2 green dots, then followed by 4 green dots, 6 green dots, 8 green dots, and then 10 green dots. These are even numbers. In the fourth row, the numbers are to be arranged in a triangular manner. There is a 1 dot, then there is 3 dots which are to be put in a triangular form. In the fifth row, the numbers are to be arranged in a triangular pattern. So if we start with 1 dot, then 3 dots to be arranged in a triangular manner. Then 6 dots again forming a triangle. 10 dots again forming a triangle and followed by 15 dots. These are called triangular numbers. In the sixth row, we will be arranging the numbers in a square form. So let us start with 1 dot, then 4 dots. 4 dots arranged in a square manner. Then 9 dots. They will be forming a square with 3 dots each. followed by a 16, which will be a 4 into 4 square, and followed by 25, which is a square of 5. These are called square numbers. Next row has cubic numbers, which are 1, 8, 27, 64 and 125. All these numbers can be represented by a cube. Page number 5. Figure it out. 1. Copy the pictorial representation of the number sequences in table 2 in your notebook and draw the next picture for each sequence. 2. Why are 1, 3, 6, 10, 15 and so on called triangular numbers? Why are 1, 4, 9, 16, 25 are called square numbers or maybe squares? Why are 1, 8, 27, 64, 125 and so on called cubes? 3. You will have noticed that 36 is both a triangular number and a square number. That is, 36 dots can be arranged perfectly both in a triangle and in a square. Make pictures in your notebook illustrating this. This shows that the same number can be represented differently and play different roles depending on the context. Try representing some other numbers pictorially in different ways. 4. What would you call the following sequence of numbers? We have 1 dot, then we have 7 red dots arranged in a circular manner with a center, followed by 19 dots forming a hexagon with 3 dots on each side, followed by a hexagon with 37 dots with 4 dots on each side. That's right, they are called hexagonal numbers. Draw these in your notebook. What is the next number in the sequence? 5. Can you think of a pictorial ways to visualize the sequence of powers of 2, powers of 3? Page number 6. Here is one possible way of thinking about powers of 2. 1 dot represent 2 raised to the power 0. 2 dots in a same line represent 2 raised to the power 1. 4 dots arranged to form a square represent 2 square. 8 dots to form a cube represent 2 cube. 2 cubes have 16 dots and they represent 2 raised to the power 4. 1.4 Relations among number sequences. Sometimes number sequences can be related to each other in surprising ways. Example, what happens when we start adding up odd numbers? 1 is equal to 1. We take next two odd numbers. 1 plus 3. This gives us 4. The next three numbers taken in order. 1 plus 3 plus 5 gives us 9. If we take 4 odd numbers in order, 1 plus 3 plus 5 plus 7, that gives us 16. Next, 1 plus 3 plus 5 plus 7 plus 9. That is equal to 25. 1 plus 3 plus 5 plus 7 plus 9 plus 11. That is 6 odd numbers. So we will get 36. This is a really beautiful pattern. Why does this happen? Do you think it will happen forever? The answer is that the pattern does happen forever. But why? As mentioned earlier, the reason why the pattern happens is just as important and exciting as the pattern itself. A picture can explain it. Visualizing with the picture can help explain the phenomena. Recall, the square numbers are made by counting the number of dots in a square grid. How can we partition the dots in a square grid into odd numbers of dots? 1, 3, 5, 7. Think about it for a moment before reading further. Page number 7. Here is how it can be done. We start with 1 dot. And then next we try to arrange 3 dots to complete a square. In the next turn, we try to add 5 more dots. This will give us a square of 3. In the next, we add 7 dots to give us a square of 4. Next, add 9 dots. That will give us a square of 5. In the next step, if we add 11 more dots, that will totally give us 36 dots, which is 6 square. And here we have taken 6 odd numbers in order. Because such a picture can be made for a square of any size. This explains why adding up odd numbers gives square numbers. By drawing a similar picture, can you say what is the sum of the first 10 odd numbers? Now by imagining a similar picture or by drawing it partially as needed, can you say what is the sum of the first 100 odd numbers? Another example of such a relation between sequences, adding up and down. Let us look at the following pattern. 1 is equal to 1. 1 plus 2 plus 1 gives 4. 1 plus 2 plus 3 plus 2 plus 1 is equal to 9. 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1 is 16. 1 plus 2 plus 3 plus 4 plus 5 plus 4 plus 3 plus 2 plus 1 gives 25. In the last row, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 gives 36. This seems to be giving yet another way of getting the square numbers by adding the counting numbers up and then down. Page number 8. There is a picture of 6 into 6 dot representation. Figure it out. 1. Can you find a similar pictorial explanation for why adding counting numbers up and down, that is 1 plus 2 plus 1, 1 plus 2 plus 3 plus 2 plus 1 and so on gives square numbers? 2. By imagining a large version of your picture or drawing it partially as needed, can you see what will be the value of 1 plus 2 plus 3 plus so on plus 99 plus 100 plus 99 plus so on plus 3 plus 2 plus 1, 3. Which sequence do you get when you start to add the all ones sequence up? What sequence do you get when you add the all ones sequence up and down? 4. Which sequence do you get when you start to add the counting numbers up? Can you give a smaller pictorial explanation? 5. What happens when you add up pairs of consecutive triangular numbers? That is, take 1 plus 3, 3 plus 6, 6 plus 10, 10 plus 15, so on. Which sequence do you get? Why? Can you explain it with a picture? 6. What happens when you start to add up powers of 2, starting with 1? That is, take 1, 1 plus 2, 1 plus 2 plus 4, 1 plus 2 plus 4 plus 8, and so on. Now add 1 to each of these numbers. What numbers do you get? Why does this happen? Page number 9. 7. What happens when you multiply the triangular numbers by 6 and add 1? Which sequence do you get? Can you explain it with a picture? 8. What happens when you start to add up hexagonal numbers? That is, take 1, 1 plus 7, 1 plus 7 plus 19, 1 plus 7 plus 19 plus 37, and so on. Which sequence do you get? Can you explain it using a picture of a cube? A picture of cube and the hexagonal is given with 4 dots on each side. 9. Find your own patterns or relations in and among the sequences in table 1. Can you explain why they happen with a picture or otherwise? 1.5. Patterns in shapes. Other important and basic that occur in mathematics are patterns of shapes. These shapes may be in 1, 2, or 3 dimensions. 1D, 2D, or 3D, or in even more dimensions. The branch of mathematics that studies patterns in shapes is called geometry. Shape sequences are one important type of shape pattern that mathematicians study. Table 3 shows a few key shape sequences that are studied in mathematics. Page number 10. Table 3, example of shape sequences. In the first row, first figure is triangle, which has 3 sides. Next is a figure with 4 sides. It is called quadrilateral. The next in the sequence is pentagon with 5 sides, followed by a hexagon with 6 sides. 7-sided figure in the next row is called heptagon. 8-sided figure is called octagon. 9-sided figure is called nonagon. And the 10-sided figure is called decagon. These are all regular polygons. Next in sequence, we have complete graphs, where each dot is connected to all other dots. First, K2, where we have two dots that are joined together. K3, we have three dots and each dot is connected. So, we get three line segments forming a triangle. Next, we have four dots and we will be joining all dots with each other. So, every dot is connected to every other dot. That will give us K4. In the same way, we take 5 dots and connect each dot to all other 4 dots, forming K5. Similarly, K6, 6 dot, each dot connected to rest of the 5 dots, forming K6. In the next sequence, we are talking about stacked squares. Take one square. In the next, we will be stacking 3 more squares to form a complete square. In the next, we can add 5 more squares to make a square of 3. In the next figure, we are adding 7 more squares to form a bigger square of 4 sides. In the next figure, we are stacking 9 more squares to make a big square of 5 units. The next sequence is stacked triangles, where we start with one triangle. Then, in the next figure, we are stacking 3 more triangles. In the next figure, we are adding 6 more triangles. In the next figure, we are adding 10 more triangles to form a pyramid kind of a figure. In the next figure, we are adding 15 more triangles again to form a bigger pyramid. Next in the series is Koch snowflake. In Koch snowflake, we start with an equilateral triangle. In the second figure, we divide each side into 3 equal parts. And we keep on dividing each side into further 3 equal parts to give us a snowflake. Page number 11. Figure it out. 1. Can you recognize the pattern in each of the sequences in table 3? 2. Try and redraw each sequence in table 3 in your notebook. Can you draw the next shape in each sequence? Why or why not? After each sequence, describe in your own words what is the rule or pattern for forming the shapes in the sequence. 1.6 Relation to number sequences. Often, shape sequences are related to number sequences in surprising ways. Such relationships can be helpful in studying and understanding both the shape sequence and the related number sequence. Example, the number of sides in the shape sequence of regular polygons is given by the counting numbers starting at 3, that is 3, 4, 5, 6, 7, 8, 9, 10 and so on. That is why these shapes are called respectively regular triangle, quadrilateral, that is square, pentagon, hexagon, heptagon, octagon, nonagon, decagon, etc. respectively. The word regular refers to the fact that these shapes have equal length, sides and also equal angles. That is, the side look the same and the corner also look the same. We will discuss angles in more depth in the next chapter. The other shape sequences in Table 3 also have beautiful relationships with number sequences. Figure it out. 1. Count the number of sides in each shape in the sequence of regular polygons. Which number sequence do you get? What about the number of corners in each shape in the sequence of regular polygons? Do you get the same number sequence? Can you explain why this happens? 2. Count the number of lines in each shape in the sequence of complete graphs. Which number sequence do you get? Can you explain why? Page 12. 3. How many little squares are there in each shape of the sequence of stacked squares? Which number sequence does this give? Can you explain why? 4. How many little triangles are there in each shape of the sequence of stacked triangles? Which number sequence does this give? Can you explain why? Hint. In each shape in the sequence, how many triangles are there in each row? 5. To get from one shape to the next shape in the Koch snowflake sequence, one replaces each line segment by a speed bump. As one does this more and more times, the changes become tinier and tinier with very, very small line segments. How many total line segments are there in each shape of the Koch snowflake? What is the corresponding number of sequence? The answer is 3, 12, 48 and so on. That is 3 times powers of 4. This sequence is not shown in Table 1. Try this. Summary. Mathematics may be viewed as the search for patterns and for the explanation as to why those patterns exist. Next, among the most basic patterns that occur in mathematics are number sequences. Next, some important examples of number sequences include the counting numbers, odd numbers, even numbers, square numbers, triangular numbers, cube numbers, Viranka numbers, and powers of 2. Next, sometimes number sequences can be related to each other in beautiful and remarkable ways. For example, adding up the sequence of odd numbers starting with 1 gives square numbers. Next, visualizing number sequences using pictures can help to understand sequences and the relationships between them. Next, shape sequences are another basic type of patterns in mathematics. Some important examples of shape sequences include regular polygons, complete graphs, stacked triangles and squares, and Koch snowflake iterations. Shape sequences also exhibit many interesting relationships with number sequences. Here we come to an end of chapter 1.
Ganit Prakash. You were just listening to this audiobook, Textbook of Mathematics for Grade 6. Narration Nidhi Bajaj. Academic Coordinator Dr. Prakash Vadigar. Technical Coordination Bati Langlingdo. Sound Recordist Manju Kumari. Assistance in Production Chetna Sharma. Directed and produced by Vimlesh Chaudhary. This audiobook is presented to you by CIET NCERT, New Delhi, India.